The first thing I want to make perfectly clear before we start making these fuel tanks, this was the invention and development of Wayne Shriven. Wayne had several years ago at Brodex allowed me to fly his twin engine Henkel with 2 carbon fiber tanks, and I was so impressed with the way the plane flew I wanted to pursue many of the ideas that Wayne had developed over the years. One of them, and he has done all the work. I am not the developer or the designer or anything. I have pretty much from Wayne's tooling made an exact copy of his tooling, and Wayne was not interested in making these for production, and I thought this would be a great way to add this to the world of products that's available to us as stunt flyers. When I got to fly Wayne's twin engine Henkel with the carbon tanks, the first thing I noticed was, wow, it felt lighter on the lines and lighter in the turn, and I knew part of it was that the plane was relatively light. I think it was even lighter than the single engine plane I was flying. But part of it was, and I've since come to realize this, that in my own case, or in anybody's case really, every plane that we fly has a weight distribution behind the CG, forward of the CG, depending on where we select to have the CG. But the fuel tank in almost every case is ahead of the CG. Now we all know other options. You build a plane, you've spent, and this is my whole point, you've spent hundreds and hundreds of hours to build this plane. And now, oh gee, it's nose heavy. Well, we all know the first thing everybody does is add solder to the tail wheel, and that makes the plane very unstable. I've not had good luck ever adding weight to the back. It's always better to take the weight out of the front. Now, if you have a plane that's already you know, in the right CG, or you don't need to adjust the CG, you really don't need a carbon tank, a magnesium spinner, a carbon back plate. You don't need any of those things. You're only dealing with here, the advantage to this would be a plane that's already built and that's nose heavy. So the first thing I would want to do, and I wanted to say this because a carbon fiber tank is a relatively expensive thing, and if you don't need it, you don't need it. The first decision you have to make is, do I need this? So I would replace every spinner part I could with either a lighter spinner. I make carbon fiber backplates. Randy has magnesium backplates. The magnesium head on the motor is another choice to get wet, but at some point in time, maybe it's still nose heavy. Now, getting between an ounce, I'm just going to put an ounce, but sometimes it comes out to significantly more than an ounce, depending on how heavy the original, if you have a tank that's heavy to begin with, but it's never less than an ounce lighter to make it out of carbon. What this has done in my case is several of the planes that I've already had in my entourage flying, Miss Ashley, the I-beam Spitfire, Mike Kajeski's plane, and Strega, and the Typhoon, have all benefited from this. Every one of them has been better because not only is the CG a little further back now, giving that light feeling, a light turn. Kent Tyser has one in his Strega. But the point was, he had never had the CG back where it was when we were at the team trials, and when he got the CG back from having the carbon fiber tank in the plane got a lot easier to fly, a lighter stick loading, a lot of trim benefits in his particular case. But again, it's not the first choice. It's easier and cheaper to replace the spinner. Easier and maybe not, I don't know about the magnesium parts for the PA. But even if you have these, and several people do, and they'd still like to have a trim tool, they'd like to have a tool and try it with that ounce and a half out of the nose. This allows you to do that. And there's no other way I know of. There's no other part that I know of that you can replace conveniently. And even in the worst of all worlds, if it didn't suit your needs, you could take it out and put it in another plane. But my feeling is it's always better to remove weight from the heavy side than add weight to the light side. A few years back, and I believe it was 95, I started getting interested in molding. And I decided at that point in time I was building a Spitfire, and I think this is an appropriate thing to decide right now too. I wanted to do some small parts. I did the little fake dummy exhausts. I made some spinners, actually made the Spitfire spinners, made some 5-bladed props, did some things like that. And then I went on to making some cowlings, These were all on that 95 Spitfire. But I never went any further. I made some spinner back plates at that time too. These were relatively simple, easy, entry-level parts to make. Nothing there was high-tech. Nothing there happened. And if something broke, something bad happened. So they were relatively good. If you're interested in molding, and if you're looking at this video, you probably are interested in molding. I then went on, and I had done this years earlier with Dave Midgley. Went back and redid some of my tuned pipe tooling. Developed the landing gear article. It's in Flying Models for the carbon. This was Howard Rush's part that I had pretty much copied, I guess is the right way to say it. Looked at the way he had made his and made a similar one. But these two parts, the fuselages on the Typhoon and Miss Ashley, I had to do that pretty much on my own. And the carbon wing I had to do on my own because nobody's done it except Kazi, and he won't sell you the parts. So the thing that's different about a fuel tank is you need relatively, all of these other parts, every part here, you can do with very, very inexpensive tooling. When you want to make a carbon fiber tank, you need to do it the way Wayne has developed. You need relatively expensive tooling. Be thinking or wondering, why does a carbon fiber tank cost as much as it does? The reason is you have to amortize the tooling, which is very expensive in this case. You have to amortize that tooling over how many tanks you're going to make. In other words, if you only make one fuel tank, the whole cost of the tooling has to go into that one tank, similar to doing a prototype. If you make two, that cuts the cost of the tooling in half. It keeps chopping the cost of this down every time you make a tank. You've spread it over a bigger line of produced parts. The material is expensive when you buy small amounts. In fact, it's very expensive. Sometimes they won't even sell you the resin. The other it's a relatively toxic material. It's not something an average hobbyist would want to have in his house, and when you use it, you must take adequate safety precautions. But the big one, the thing that makes this different than all other parts that I make, is it is really labor intensive. The molds have to be prepped, they have to be cleaned after every use, and the parts are so thin and so delicate when they're being made that it's relatively labor intensive. So when you combine all three of these, you just can't make the parts very inexpensive. You could make them a little less expensive if this part becomes very, very popular, and you can tool up to make 50 at a time. That's going to cut the cost. It cuts this cost a little bit. It cuts this cost a little bit. But it never cuts this cost. This cost is a constant. You're never going to be able to make these in an automated fashion. Each one is handmade. Each joint has to be hand ground. Every one is a little bit of a labor of love. First part is the end cap part. These were machined by Jimmy Snyder and a relatively accurate copy of the ones that Wayne was using. It's a male-female part that rides on pins. And I think you can figure out that when you want to make a carbon fiber part as light and strong as it possibly can be, and obviously we're really pushing the limit here. I mean, I think we're right up on a limit that even if you had access to more expensive equipment, you couldn't make that part a whole lot lighter. But to make an end cap, here's an end cap that came out of the mold this morning, and you can see it's really squeezed and squashed every drop of extra resin. The idea is to get the carbon content high, the resin content low. I think we've done that. And he's got a set stop on here that when that squeezes, it's to a very, very specified thickness. These we've cut one apart and mic'd it all over to see it's very, very accurate. Anyway, what happens, and it's the first part of making a part. And I wanted to show this in the sequence that we have in. When you take a mold apart, it's full of little drops of resin and goop and everything. And the first thing, and whether you like to do it or not, beside the point, because you really do have to do it. And I just dropped my knife on the floor. I always have some kind of a blade that I go around. And this is an ordinary Stanley blade. And you can see what I'm doing, just knocking these little pieces of resin off. Now, cleaning the mold is a real important part of getting nice, really accurate parts. We have a reamer that we run down through the holes after every cycle, because no matter how you do this, some resin is going to drip on it. And I like to get all these extra. If you don't do this after every cycle, what happens, you don't get a wax buildup. And then it just turns into stalactites and stalagmites, and God, it just makes such a mess, it's unbelievable. Now what I'm going to actually show is a complete layup of one tank, and then an assembly. But this is, and I'll just do one part to show just about how much effort goes into this. It's labor intensive. You cannot skip this step. You cannot just go out and make another part without cleaning the mold. This is part of what we have to do every cycle. It's generally about a 5 or 10 minute job, but I'll take one of these little pads. Now I never go down into the machine part because that part already has many coats of wax on it. And what happens with a mold, when it's new, they call it a green mold. And after it gets used, after that part gets pulled on a molecular level, it gets smoother and smoother and smoother and easier to release the part. In other words, a new mold is the hardest part you'll ever release is the first part. And from that part on, the mold gets smoother and smoother just from the use it endures. But anyway, this is again why it's labor intensive. Now normally about every 5 cycles I'll go through and clean the ends of this up just for my own use, because I've paid so much money for this tooling I don't want to see it deteriorate. And I expect to use this, I hope, until the time I retire from the business or sell the business to somebody else when it's my time to go. But anyway, cleaning these parts up and maintaining them, labor intensive. No different on this part here, but I don't want to go up onto the part that I'm going to be using. You see right there, and a lot of times you can get it off with your fingernail, a lot of times you can't. And see how some of the stuff is in the holes? I just gently hand run a reamer down there. That's the exact size, because these are very, very tight fits. They have to be hammered together and they have to be unhammered to get them apart. A lot of times when you're cleaning up a mold like this, just having your fingernail will actually help release it, and it doesn't scratch the mold. See, up in here I don't like to scratch it. Again, it's not an instant thing, it takes time. And no matter what mold, even if you have, like on our wing mold, fuselage molds, the molds always have to be prepped. People that aren't familiar with molding operations, the molds always require a little bit of preparation between each cycle, and then they need to be prepped so that the epoxy doesn't stick. This part of the prep is always, if you see on the pins always are subjected to having some resin, and this resin is a very, very tenacious resin. And once we start laying up the parts, it does get kind of sloppy. You really can't, you have rubber gloves on and you have other things, aprons or whatnot, and it's difficult. All the cleaning has to be done before you start the part. And that's a tight fit. I can pick the part right up by that. The cleaning the pins, another thing that's real important, because we want to press fit, and I don't want them to lock up and stick. When they lock up and stick, or the part sticks, it's called a catastrophic lockup, and that means you're not getting the part out, or you'll not have the part and you'll destroy the mold. It is true, and I go back over and over again with all the planes I build and fly. I always try to get the CG further back, further forward, further back, because there's always a spot where it suits me. There's other spots where it's going to suit other flyers, a better skill level, less skill level. But there's always a spot that's right for you. And if you have all these tuning tools, what you find out is you can set it easily. When you don't have the tuning tools, now see, that's still got a little bit of resin on it, or there's a little bit I got to run the reamer down through there. Having the tuning tools is so important. Now at this point I drive the pins in side just till they bottom out. And now both of these parts are ready for their waxing operation. But first I want to prepare the main body at the same time so I can do all the waxing in one cycle. This is the bottom half, or the top half as the case may be. There's two that match. There's a third part that's an interference part, and you can pretty much see we have a mandrel that's highly polished. It's 9 inches long. It has one end that we use this to bead on, because you'll see when we go to disassemble this, and Wayne has really engineered this up well. I think Wayne's a professional mold maker, but I'm not sure. If he isn't, he should be. Anyway, that kind of fits in there with a fit. That's the wall thickness of our tank. And we have another piece that slides in from the side. And when we actually assemble this, we will wrap on the end of it a piece of carbon fiber tow so that we can then beat the mandrel out. I just wanted to demonstrate this because when we start beating, this really gets, this will come out, and when we take this piece out, we'll have our tank body, we'll have our tank shell in one piece. That wrapped end that you can see when that comes out of the mandrel. This part is typically in here, like so. And what happens we drive out the center mandrel, then take the clamps off, take this piece out, and this is our remaining piece. And you can see what the quality of finish on the inside. Of course, this all gets trimmed away. We have 2 laminates of 1/2 ounce cloth, 2 laminates of carbon, and it's relatively nice and smooth in there. Again, I think Wayne did just an unbelievably good job of engineering this up. This is way out of the realm of me engineering it up. This would never have happened without Wayne. Wayne had loaned me in the past prop molds that I've made props from. Helped me in almost every way you can help somebody. And really, as far as I'm concerned, one of the most helpful people that I've ever met in the world of model aviation. Always enjoy having a little talk with him on the phone or exchanging technology. And by the way, his website is NIVIRT spelled backwards, and you can see how he makes his own motors from scratch, just to give you an idea of his skill level. Anyway, the skill level isn't worth anything if somebody's not going to share it with you, though. And my next thing is I'd like to share it with the people that just like to see how this part ultimately gets made. In the same way, I would love to see how they make a motor from scratch. And I'm certainly never going to be able to tool up to do it, but I'd love to see how they do it. And you can see here how we've squeezed out all the extra resin. There's virtually no resin that doesn't have to be there. So I won't bother doing on video because it's just redundant. I like to clean. If any of this looks like it's getting in rough shape, usually this part doesn't have any extra on it. This piece typically needs, here's a little shaving of stuff that can come off here. And then once I get this cleaned up, it's pretty much the same as doing the other stuff. I try to clean the big stuff up with a blade or my fingernail. And you can see the stuff coming off right now. You can see a skin coming off. Out here it's not really important. It's just for my own. I just like to have the part clean. Again, I would like to have, and it's something that I've been able to do with the carbon fiber gear mold, is just get an infinite life out of the mold by constantly maintaining it. If you're only going to make 1 or 2 parts, this part you can gloss over. Anyway, we're ready for the waxing operation. Now there's several ways to release parts. PVA, silicone spray, but the best one, and Wayne is the one that turned me on to this, it's available from George Spar Aerospace Composites. He's in all the newsletters, in his ads. And it's not the ordinary part-all wax. In fact, even the bird likes part-all wax. By the way, if you don't know, this is Peeps. He's my shop helper. He helps me prep molds. Get out of here. High temperature wax. Now the reason I think that Wayne preferred the high temperature wax, and the reason it works well, is we put these parts in the oven to cure before we take the mold apart. This wax so far has been wonderful on releasing parts. Available again from George Spar Aerospace Composites. In fact, all the material we have, the carbon, Everything except the resin is available from George Spar. Information for anybody that needs it. And George, by the way, is excellent with tech help. A good friend of mine, I taught his son to fly years ago when his son was the junior national champion in 1982 or 83. Shows you how good my memory is. Anyway, always helpful if you're interested in any kind of molding technology. George Spar, Aerospace Composites. Anyway, this part needs to be extremely clean because these parts come right down like a vise. Even a little dot on here gets the clearances wrong. So again, I'm real careful. I don't want to scratch it. You can see all the stuff that actually does those little resin deposits. Now I'm not going down into the part. Again, it's preparing and cleaning this up that results in having that really nice finish on the part too. So it allows the mold to close perfectly then instead of almost perfectly. And about every 5 times I'll clean all this off the side of the mold. But the point is too, once you have a good quality tool, forever and ever and ever and ever, you can make parts. Once you have a mold for any part and it's polished and you're getting parts releasing, it's the last time you ever have to make that part other than just mold up another one. From this point on, I like to take all the safety precautions. I have a fan going for ventilation. I have an air conditioner going to keep the shop as cool as possible. The cooler it is in your shop, the more work time you have with the resin. If you have a shop where it's 72 degrees, that's good. If you can get it to 70, even better. If you can get it to 68, at some point in time you'll have a little extra work time. And this resin, the more work time you have, it just makes it easier and easier to use. Now I've used several different, in the course of learning the little tips of the molding operations here, several different tricks, several different PVA for one, silicone release agents from Smooth On. They all work in their own way, but this is by far the best one. Now typically what you do is you wax a part, make sure you get a good thin coat, buff it, polish it. Well, there's several ways they even tell you to do it on the can, but the best thing is to make sure you don't have any spot on a whole mold that doesn't have wax, or else you will not be able to get the resin off easily. So even over this old resin and everything, I try to get a coat of wax because this is going to ooze resin when we're done. There's just no way you can make this neat and easy. Now, I usually would put, on a new mold, I'd put 4 coats. I'd wait an hour. I'll buff this off about a minute later, give it about 60 seconds. Wait an hour, give it another coat, and then repeat that cycle about 4 times. But once a mold gets used and it's not green anymore, what happens is you can get away with 2 coats or maybe even 1 coat. Now in this case, this is the part that's going to be the most difficult to get out. The shells will just come apart, the end cap, but this part is the one that I never don't give it 4 coats of wax. I always give it that extra time. Now the way you know that it's drying up real nice is you can just sit just like buffing out a plane. You can take one little spot and really get it nice. As soon as you see you've got that nice high gloss on it, and you can see that, you just need to do the whole part. And now this prepping operation can be just take time. There's no way you can speed this up that I know of. And if you take that chance of not getting enough wax on everything, you run the risk of losing the money you've paid for the tooling. So this part of it, this is the one part, if you're new to molding, you just can't skip this part. This part, it's always, you want to get busy and you want to go do it. But what I do, because I always schedule my work, what I do, and it's a good way to do this, is while 1 coat of wax is drying and I'm waiting for the next coat, I can cut all the material for the next operation. And that usually takes 10 or 15 minutes. But if it's a new mold, give it that 4 cycle, an hour apart. And even then they recommend letting it dry overnight on the first pull. But this is the part that I don't want to have any chance. Now I'll do the rest of them off camera, but it's just labor intensive. Wax on everything. I like to wear rubber gloves because what happens is my hands get so dried out from alcohol and acetone and different things that when I get a little cut, I don't want to get wax, I don't want to get resin. You actually should, from this point in the job on, always be wearing rubber gloves. You never want to get this resin. It's Epon. You don't want to get that resin. It's the same resin they make propellers out of. That resin is not, it's not good to breathe it. It's certainly not good to get it on your hands, and as soon as you're done with the layup, you want to get it out of your shop. You don't want to sit and let that cup with extra resin just sit on the workbench. Get everything outside. In fact, as soon as we really get to a little bit better weather in the season, we're going to be working out in the garage. We're going to try to set up a molding area so we don't have to even do this in our shop. But we do while the resin is exposed to the air, keep that time to a minimum. One example of something that's important is all the little radiuses here. And even though I've not cleaned this, I try to get wax on everything because eventually at that 5th pull or 6th pull I want to get some of this, I'll want to get it cleaned up. I don't want to turn it into, you know, the Howe Caverns or something. Anybody that I've ever talked to that's had problems with molds releasing, it's always that they try to rush the preparation or try to, in some way, they try to save time or whatever. And this is the one part of the job. There's parts you can kind of save a little time on, but this is certainly not one of them. Now, I don't want you to confuse, for people that might not be aware of, there are thousands and thousands, maybe even more, formulations of epoxy that are made for specific things, like SIG epoxy glue. All products that are 2 parts and you mix them together are toxic. They're not good for you. In small amounts, they're not going to kill you. Some people are sensitized to it, some people aren't. But there is no such thing as good epoxy. Epoxy is not good to breathe. It's not good to get on your skin. It goes through your skin, certain types. The type that we're using is not really a hobby product. You're not even supposed to be able to buy it. There's only a few places that will even sell it to you without you demonstrating that you're, you know, in compliance with the EPA regulations. So keep in mind, this is not a product that we could make with 5-minute SIG epoxy. You need to have high-tech, very expensive, very specifically formulated epoxy. You just cannot get away with all epoxy is not the same. Now, we also are going to do some tests in the future. Ed Gallagher has sent us some vinyl ester resin that's made specifically for this application, for making fuel cells. And it's very chemically resistant. We haven't tested it yet. But I'm hesitant to change anything that Wayne has come up with because his stuff works perfectly. And his tanks, the ones I've